To do that, I get to see certain patterns where I have this theta 1 minus theta 2, this theta 1 minus theta 2, 2 minus 3, 2 minus 3, 1 minus 2, 2 minus 3. I only got these two types, 1 minus 2, 2 minus 3, these two types. And why these two types are important? So that I can then do my coordinate transformation. Right? If you don't use that way, if you can find other coordinates of transformation, that's fine as well. Yeah. But you must identify two that you can use for your coordinate transformation. Which are the two? The first one, theta 1 minus theta 2. I call this phi 1. The next one will be theta 2 minus theta 3. It's 2, 3, 2, 3, 2, 3, 1, 2, 1, 2, 1, 2. So I call this phi 2. So these two are my principal coordinates. Principal coordinates that we learned just now, where I was using Q1 and Q2 to represent, but now I use phi to represent. So if I were to differentiate two times, then I get theta dot dot 1 minus theta dot dot 2. And differentiate two times as well for this. So the marks allocation so far, this will be 2 marks, 2 marks. So once we have coordinate transformation, these principal coordinates, so these are these two. These are your principal coordinates. Once you have them, then you can substitute into 4. So if you substitute this into equation 4 over here, so you have a little bit of adjustment, you get I phi dot dot 1 plus k R2 over 2, phi 1 minus k R2 phi 2 equal to 0. Right? Because you can substitute your principal coordinates. I call this equation 6. So for your equation 5, then it becomes I phi dot dot 2 minus k r squared over 4 phi 1 plus 2 k r squared phi 2 equal to 0. I call this equation 7. I'm going to need about 6 more minutes to the end of this. It's grade 11, so I just want to complete this question. So that's a part that you're asked to show. So it's shown. So each of these 1 mark each. So part B, it asks you to find out what are the resonance frequencies or your natural frequencies. So in free vibration, your phi 1, we're going to assume that it has this kind of motion. And your phi 2, it has this kind of motion. So if you look at your system, as it oscillates, you will have a sinusoidal oscillation. So differentiating it 2 times, so minus a1 omega squared sine omega t. Differentiate 2 times, a2 omega squared sine omega t. So we're going to substitute it into 6, equation 6, for this one. And since I'm always canceling sine omega t, I'm going to leave it out. So I'm going to have minus I a1 omega squared plus half k r squared a1 minus k r squared a2 equal to 0. So all this sine omega omega t, I kind of like leave them out, right? Because they'll be canceled anyway. So no time, yeah. So that's why you need to leave things out. So if I were to simplify this, bringing all the a1s and a2 together, just a1 over here. So half kr squared minus I omega squared a1 plus k r squared a2 equal to 0. I call this equation 8. So from your equation 7, we substitute this form, again leaving out your sine omega t. So I have minus I a2 omega squared k r squared over 4a1 2k r squared a2 equal to 0. So again, the sine omega t is no longer there, and then I'll bring all the a1s and a2 together. So I have minus k r squared over 4 a1 plus 2k r squared minus I omega squared a2 equal to 0. This is equation 9. The marks distribution 8 and 9 respectively 1 mark. So now we can form the matrix. A1 and A2 matrix. So A1, A2 must be equal to the other side 0, 0. So this form over here is half kr squared minus I omega squared minus kr squared minus kr squared over 4, and then this 2 kr squared minus I omega squared, right? A1, A1, A2, A2. So in order to solve for the non-trivial question, non-trivial solution, that means I need to equate the determinant equal to 0. So that means half kr squared minus I omega squared 2k r squared I omega squared minus kr squared multiplied by kr over 4. Kr squared over 4. This equal to 0. So the distribution for the marks, this one is 1 mark, this is 1 mark. So now is to try to find out what is that omega. So I'm going to multiply it in. It's a lot of just algebraic expression, because they didn't really give a constant. So I'm just writing down after you multiplied it out. That form. Okay. So again, you could see that's omega to the power of 4. So if I were to simplify it into the 4th order expression, and then use the quadratic equation to find out what is omega squared. So it's going to be quite big. Plus minus 5 over 2 kr squared I squared minus 4 I squared 3 over 4 k squared r to the power 4 divided by 2I squared. So this plus minus square root. Now this part here, you can see that the two terms over there, they are very similar. Eventually, you work it out. 5 over 2 squared minus 3 k squared r to the power 4 I squared. So now I could bring out the common factor k r squared I, right? You square root that. So that will be k r squared I. And then the numerics 5/2 plus minus square root 13/4 divided by 2 I squared. So this and this could cancel. And 1/4 5 plus minus 13 square root kr squared over I. So this part here, 2 marks. So finally, your omega squared, 1/4 5 plus square root 13 kr squared over I. And the other one, 1/4 5 minus square root 13 kr squared over I. So your omega will become 1.4667 r squared root k over I, or 0.5934 r squared root k over I. So this will be your 1 and this will be your 2. So I'm going to open up your practice questions. Just in case you didn't know, in your Moodle, I've also given you, besides the assignment, there are more practice questions for you to practice. I also noticed that some of you submitted assignment 2 without attempting all of it yet. So what I want to say is that this is the best time for you to form study groups. So if you don't know how to solve questions, better form a study group to help each other. Why that? Why helping each other can be a joy? That's because then all of you can get A1 grade, right? Because Glasgow do not moderate your grades. Yeah. So if all of you get A1s, it's not moderated. Okay. So then why not all of you get A1s and help out each other? Right? So form that study group and then attend your practice questions. I'll see you next week.